Okay, let's look at this one here. This time we've got these weird cyclopropane things. Kind of one of the hardest things to visualize, maybe. But just remember, this is just cyclopropane, but instead of having the ring in the plane of the board or the screen, this time we've got it kind of almost perpendicular to the plane of that board, so that it's kind of coming out at us, as we can see by the wedges here. Okay, so like in all three pictures, the pink carbon is going to be the one closest to us, whereas the green and the orange ones, they're equally far away from us. You could imagine those being in the plane of the board with the pink one coming towards us. Okay, so to distinguish between them, though, probably the first thing to see is that on the first one and the third one, we've got the methyl. There's two methyl groups, and one is going down, and the other one is going up. Okay, and that's also true here on the third one. One's down, the other one's up. On the middle one, though, both of them are down. Okay, so that means there's no way that 1 and 3 could possibly be the same thing, or the enantiomer of 2. Okay, because if I draw the mirror image of, say, 1, it's also going to have a methyl group up and a methyl group down. They couldn't possibly be on the same side when I draw the mirror image. So there's no way these two are mirror images, and there's no way these two are mirror images. Okay, so they're definitely different compounds, and since these are all stereoisomers of each other, they have to be diastereomers. Okay, so 1 and 2, they're diastereomers, and 2 and 3 have to be diastereomers. Okay. Now, 1 and 3 are harder to tell apart, because one of them is up and the other one's down with the methyls. Okay, and that's the same over on 3. But I don't know right away if they're superimposable or if they're enantiomers. Okay, there's basically, you can either do this by kind of trying to move it around in your mind and seeing if they match up, or probably if you're not that great at that, and the only way to get better at that is to use your model. But if you're not that good at it, it's probably going to be easiest to just go ahead and name them with the R and S labels. To do that, let's draw the cyclopropanes in the plane of the board. Okay. Oops. Okay, so on the left, the green carbon, that's going to be right here. And we can see that the methyl group is coming down if we're looking from above over here. So I'm looking this way. Then the methyl group is a dash. And on the orange carbon, well, that's going to be right here. This time the methyl group's coming up towards us when we look from above, so it's a wedge. Now let's do that over here real quick. We've got this orange carbon, methyl group is coming towards us, that's a wedge. And the other one is going away from us, that's a dash. Okay, now that we've done that, let's try and name each one. Okay, so let's start with the green one over here. The hydrogen is coming towards us, so we're going to have to remember we'll need to switch everything since we want the hydrogen, which is the lowest priority, to be going away from us. Alright, but let's figure out the priorities of everything bonded to the green carbon right here. Alright, so the highest one, that's going to be this orange guy. And I know that because if I go one carbon away from the green one, in all directions I get a carbon, another carbon, another carbon. Okay, so they're all equivalent so far, but then let's go another spot. Over here, everything's hydrogens. On this one, there's 2 hydrogens and then a carbon. And then on the last one, there's 2 carbons here, and then 1 hydrogen. Okay, So the one with the 2 carbons and the hydrogen, that's going to be the highest priority 1. And then this one had 1 carbon bonded and 2 hydrogens, that's 2. This one has 3 carbons and no hydrogens, that's going to be number 3, with the hydrogen being the lowest. Okay, so I'm going from highest to lowest this way. That's clockwise, so that would be R, except the hydrogen's coming towards us. We want it reversed, so that means this one must be S. Okay, so let's declutter all of this stuff. We said that one was S. Okay, now how about over here? Same deal. The one going around the ring towards the methyl right away, that's 1. Away from the methyl is 2. Sorry, I should be clear about that. When I said towards the methyl, I was talking about that methyl. So that was 1. This one was 2. And then this methyl group is going to be number 3. And the hydrogen, which is a dash, is the lowest. So it's behind the board. That makes it easy. We're going, this way from highest to lowest. 1, 2, 3. That's counterclockwise, so that makes this one S. Okay, very good. Now how about over on the right side here? Let's remind ourselves what we're doing. We're saying if these two are both S, then they must be the same compound. These would be equivalent if they're both S. If one of them is switched, but only one of them, that would make them diastereomers, and that would be this guy or it's an enantiomer. Okay. And then if both of them are switched, then these two would be enantiomers. So that would mean if this was R and that was R, then 1, this guy, and 3 would be enantiomers. Okay, so we need to figure out, really we know they're either going to be both be S or both be R, okay, since these two are both S. Alright, so let's start with this orange one. Highest ranked is going to be here. There's 2, and there's 3. Hydrogen's going away, so that means we're going this way. That's 1, 2, 3. That's clockwise, so it's R. Okay, get rid of all this real quick. R. Alright, and immediately, like I said, they had to have either both switched or both stayed the same, because if only one switched, then they would both be on the same side of the ring. Okay, hopefully that makes sense. If not, we can talk about that later, or I can try and clarify later. But just to practice and make sure, let's name this again. So we're going to name this carbon number 1. Priority is there. Here's 2. Here's 3. Okay, so highest to lowest is this way. That's counterclockwise. But this time the hydrogen is coming towards us. So if we're looking from the other way, that will be clockwise, which is R. So this one's R. So just like we predicted, since the first one changed to R, we knew the second one was going to also change to R. Now, since these two are both S, these two are both R, that means they must be enantiomers of each other. Okay, so 1 and 3